Welcome back to Lamar's what? Theory. I am your one and only the labs, aka Mommy, like my friends do what? To call me. Now, let's now start the business. So we are now moving on, we are going to talk about what? Differentiation. So under the differentiation, we have on the different aspects under the what? Differentiation, we have the sum, we have the product rule, we have the sum rule, we have the chain rule, we have the quotient rule, we have the implicit rule. So all this, we are going to talk about it one by one. But before we talk about all these one I've mentioned, first thing we are going to talk about what? The first principle. Differentiation by what? By first principle. So we have this graph. So if you look at this graph, we have is having a slope, is having a x plus ds, is having y plus dy, and so on there. So where we have the horizontal, and we also have the what? The vertical. So we are going to use this graph to prove the equation to solve first principle. Now let's start now. Okay, now let's start. Let's consider the function. Consider the function. Now, all the function. So we have y equals to what? F of s. So let's call this one what? Equation 1. So when we call this one equation 1, now from the graph we have y plus dy equals to fs plus what? ds. Let's call this one equation 2. Now, when we have this, if you remember, we have under simultaneous equation we have elimination what? Elimination method. So we are going to apply that to this. So we are going to subtracting equation 2 from 1. Subtracting equation 2 from 1. Now, our equation 2 is y plus dy. What's our equation 1? Minus y equals f open bracket s plus ds minus f of s. Are we together? Okay. Now, this one now we are going to collect what? Collect the like term of the side. So where we are going to have y minus y plus dy equals to f open bracket s plus ds minus what? F of s. Are we together now? Okay. So now, y we cancel y. So we are left with dy equals to f open bracket s plus ds minus what? F of s. Now, when we stop here and we have something like this, then we are going to introduce what? The s to what? To both sides. Then we have dy ds equals to f of s plus ds minus f of s divided by what? Divided by ds. Are we together now? Now, if you look at the graph where we have the slope. Now, the slope of the graph is telling us that where we can have limits where the s tends to what? The s tends to 0. Where we can have limit the s tends to what? 0. So we now have lim the s tends to 0. So we have f of s plus ds minus f of s divided by what? Divided by ds. Now, so this formula now is that we are now going to use it to what? To solve our question when we are asked to use what? To use first principle. So now let's have a short break. So when we come back, we are going to have a what example how we can apply this wonderful wonderful formula that we derive from what, from our graph. Stay tuned. Gamma theory. Now that we have proved the formula by using that graph. Now let's look at the example by using first principle. That's the first step when we're talking about differentiation, before we move to the other aspect, where we are going to be using the sum rule, the product rule, the quotient rule, the chain rule, the implicit rule, and so on and so forth. So let's start with by using first principle to solve this question. Now let's go. Okay, now we have x squared, and the number 2 is 3x squared. Okay, now solution. Now let y equals to x squared. Are we together? Let y equals to x squared. So we can also call that one equation 1. Are we together? Okay, let's call this one equation 1. Now if you go back to our proving, we have something like this, where we have y equals to f of s. We call that one equation 1. Now that's where we are going to make use of our equation 2. So our equation 2 is then we have y plus dy equals x plus dx square. We are going to square it because we are having square here. Are we together now? So we are going to square this because we are having square here. Now let's subtract equation 2 from equation 1. Now we have subtracting 2 from 1. Okay, now our 2 is y plus dy minus y equals the open bracket s plus ds square minus x square. Are we together now? Okay, now we collect like time here so that we can eliminate this y. So we have y minus y plus dy equals to x plus ds square minus x square. Are we together now? Okay, you can see that it's lovely. It's step by step. Okay, so y we cancel y, which is 0. Now we are left with dy equals to open bracket x plus ds square minus x square. Now we are going to expand this. We are going to expand this, where we have dy equals to x plus dx open bracket x plus dx minus x square. Are we together now? Okay, now we have dy equals s times x, that is x square. Are we together now? S times ds, that is plus s ds, plus ds times s, that is s ds. Please don't go and say when I say x times ds, don't go and say the x square. No, the x is like is a variable. Are we together now? Where this one is called the s. So where this one is just is just a variable. So don't try to mix it together. Okay, now let's continue. So we have x squared plus x ds plus s ds. Are we together now? Now the s times the s, so we have plus the x squared. Are we together now? Okay, minus x squared. Now we cannot say dy equals x squared the x ds plus s ds, that is plus 2s ds. Are we together? Plus the s open bracket and close bracket square minus what? X square. Are we together now? Okay. If you notice something, you will see that this variable x square and this variable are what? Are the same. So we are going to bring the what? The two together. So where we have dy equals to x square minus x square plus 2s ds. Are we together now? Plus ds close bracket what? Square. Now this we cancel this, which is what? That is 0. Now we now have dy equals 2s ds plus open bracket ds what? Ds square. Now this is now where we are going to introduce our what? Our ds. We are going to divide through by what? By ds. Then we have dy over ds plus 2 equals 2s plus dx square divided by what? Divided by ds. Are we together now? Okay. So now we can now say dy over ds equals 2s ds over ds plus dx square over what? Ds. So ds will cancel ds. Okay. Now we all know that this one is twice. So ds one here, ds one here. This one will remain what? Ds. So we have dy over ds equals to what? 2s plus ds. So that is when that slope will what? Will now come in, which is limit ds tends to what? 0. So where we have limit ds tends to what? 0. So where we have now, we have dy over ds equals 2s. So what's our ds? Which is what? 0 plus 0. So we have dy over ds equals to 2s. So that is for what? X squared, where we have y equals to what? X squared. So that is the derivative of what? Of x squared. Are we together now? So now let's have a short break. So when we come back, we are going to do what? The second what? The second example, which is what? 3x squared. Are we together now? Stay tuned. Don't go. I'll be right back. Thank you. To Lamar theorem. So now let's continue from where we stop, because we actually have a short break. So we are through with x squared. So we are moving on to what? 3x squared. Are we together? So let's start. So don't do. So still grab your paper and your pen. Are we together now? If possible, you order what? You order popcorn or snacks. Don't worry. All bills on me. I'm going to settle what? I'm going to settle the bill for you. So let's do this together. Now, let's do 2. Solution. So we have 3x squared. So we are going to have y equals to what? 3x squared. Are we together now? So we are going to consider this one to be what? Equation what? Equation 1. Are we together? Now, our equation 2 will now be, then we have y plus dy equals to 3 open bracket. Are we together now? X plus the x squared. Are we together now? Now, this is the square here. So the square is going to affect what? This s plus what? Plus the s. So now we have to expand this before we can subtract equation 2 from what? From equation 1. Are we together now? Then after we expand, we are going to use this 3 to multiply what with what? Up to expand. So now let's solve for this now. So where we have y plus dy equals to 3 open bracket. Now the expansion of this one will give us x squared plus 2s ds plus ds squared. Now, are we together now? If you look at the previous one that we did, which is what? X squared. You see that expansion of x squared is this. So I don't need to what? To break it down again. Are we together now? Okay. So let's now have y plus dy equals, let's use this 3 to what? To open the bracket of this. 3 times x squared, that is 3x squared plus 6s ds plus 3 ds squared. Are we together now? Okay. Now, when we have this one now, let's now what? Subtract. We're going to what? Subtract. We're going to subtract 2 from what? 2 from 1. So subtracting equation 2 from 1, subtracting 2 from 1. Are we together now? Okay. Now, our equation 2 is y plus dy minus y equals, are we together now? So we have 3x squared plus 6s ds plus 3ds what? 3ds squared minus 3x squared. Is it clear now? Okay. Now, let's collect the what? The like times now, where we have y minus y plus dy equals to 3x squared. This one will come here, where we have 3x squared plus 6s ds plus 3ds squared. Okay. Now, this will cancel this, then this will cancel this. So we are left with dy equals 6s ds plus 3dx squared. Are we together? Now, actually there is fun here. Are we together now? So that is the what? The beauty of what? The beauty of mathematics. So I'm actually enjoying the way I'm solving it. Seriously. So let's continue. Okay. So we have then I'm going to introduce what? ds. So here we have dy over ds equals 6s ds plus 3ds squared over what? ds. So we have dy over ds equals 6s ds over ds plus 3dx squared over ds. Okay, ds will cancel ds here. Now this is 2ds here. So this one will eliminate. It will remain what? 1 ds. So we have dy over ds equals, we have what? 6s plus ds. Are we together now? So we are going to have limit ds tends to what? 0. Limit ds tends to 0. So we have dy ds equals to 6s plus 3 open bracket 0. So we have dy over ds equals to 6s plus 0. So dy over ds equals to 6s. Okay, so that is the beauty of what? That's the beauty of mathematics. So you can see the way we actually what? Solve it. So when you are less busy, you can actually what? Solve more questions. Are we together now? By trying this, where we have s raised to power what? 3. Are we together? Or you try 1 over what? S 1 over what? 1 over x. Any one of the two. Are you together now? At your fifth period, you can try it. So that is that will be all for this what? For this episode 14. Under episode 15, I will still going to talk about the differentiation. So under that differentiation, that maybe that